Okay, so last time we created this one for practice task 3, and we also started the drawing. So I haven't, I'm logged in at group B right now, so I need to change my project first before we start. So I need to change back to 3A, so that I'm on my correct group here. And then I can do open. And first I'll just open the part file, just to have it open in the background. This one is always a bit slow. So. And then I open the drawing itself. Yeah, we have put in a section view. We had put in a section view so that we could better show the shape of the holes in this one. In order to make this a bit more easy to read when I'm going to put on notes on the holes, I'm going to move the AA mark for the section. I'm going to move it to below the section instead. It is usually given below the section, but I see that Inventor often places it on top of the section. Then I'll go over to the annotate part of the toolbar. And I'm going to use the hole and thread function. Then I'm going to click on this hole on the side here. I need to switch from standard to method 1B. And then it says a 20mm hole that's going all the way through. I can do the same on the middle hole. And you can see that I'm getting a lot more information here. So what it's showing me is that I have a 20mm hole that's going all the way through, but on one side I have a counterbore that has a 40mm diameter, and that one is going 5mm deep. So those are the counterbore is the sort of almost a rectangle shape without a top. That's a counterbore showing with the diameter, and then we have the line with a downward facing arrow on that shows the depth of the counterbore. So this is a way of giving the dimensions of it without actually having to put a lot of dimensions line inside here. So it's a good way of showing everything. Now I can either just put on a 20mm hole all the way through on this one, or I could have fixed the first one and set it to be 2 times 20. It doesn't really matter on this one. I could also use the tip behind it in order to show that it's a typical hole. In this case, I'm going to just let all 3 of them stand because I'm not going to place more dimensions on this section view except the thickness of the plate. So I'm going to use a regular dimension. So now I've switched dimension type, so I have to switch back to method 1B in the formatting. And then I place the height or thickness of the plate. So we have already given this center hole to center hole dimension, and we could also give a radial dimension here over on the side. Need to have it in 1B there. And the R20 here is repeated on the other side, so I'm going to just put tip on it. because that one is repeated on both sides. Actually, I don't need to put typical on it either, because we have a symmetry line here, so we can actually just drop the whole tip one. Then we're going to place another radius, because we need to show what this top part here is. It has a radius of 40. So we need to locate it with the mouse so that we get just a curve up top there. We want to place a radius on it. And again, we have these symmetry lines. We have a symmetry line going over here, and we have a symmetry line going over here. So if I put a 40 on top there, I was a bit too quick with my mouse button clicks there. So just R40 on that one. So the R40 here will be mirrored across the symmetry line onto this side, and the same with the R20 here will be mirrored over to this side. So we don't need to put the typical ones on them. That is basically what we need of dimensions. It could be nice to put up a dimension from the outer points on one side to the outer point on the other side, just to show the total length of it. But then we actually have to put it in as a reference, so we need a parenthesis around it. So I'm putting it in here. And then I'm moving over to the Precision and Tolerance tab. And I choose the Reference option. Because then you can see we have already gotten a parenthesis around it. Because we have given the entire length, we have set 180 plus minus 0.2 between these center points. And we have also given it that it is to be R20 with the same center point there. So we have actually given the total length of the piece, and this length here is just to make it very easy for whoever is creating it to read what it is. Then we need to put in some more information. We would want some general notes, and we want material, and we want general tolerances, and we want notes. So I'll do the material first, which is what takes the most time. Use the parts list. Select one of the views, and then click OK. Place it on top of the title block, like this.
Parts list and then what?
Yeah, I've just placed the parts list. I haven't done anything else yet. Once you have placed the parts list, then you can double click it.
You have to click your item, what you want. No, you're right. Press pointer. And I ask you which part is this one. Press it. Press Y.
Then we go to table layout up there, where I've got my mouse pointer. I'll just get the tooltip up again. So table layout. And I uncheck the title one, because we only have one part, so we don't need a full list of it. And then I go to the column chooser. Click the column chooser, and I remove the default properties. And then I find the one named material, and I add it. And I click OK. And now it already says that I have a material of stainless steel here. So I'm going to click OK again. And now my parts list has been updated, and now it only states the material of this part. I think it looks a bit better if I get stainless steel on on one line, so I'm just going to expand the table a bit. So I mark it, click on the side here so that I can pull it, and it automatically shows me as soon as it's got it over on one line. Then I move it into the corner. Then we're going to do general notes, general tolerances, and notes afterwards. We need to use the text function up here. Just place it somewhere in the vicinity of where we're going to have it to begin with, until we see how much space the text is going to take. General tolerances and surface finish. We have the ISO 2768-1. And in this case, I had set medium. And then we have ISO 2768-2. And it was set to K, capital K, which is the equivalent of medium. Most of you hadn't put in the material and the general tolerances and stuff in submission 1, which is all fine. No one has gotten any marks for that. I've only written it in with blue. That it would be nice to see it. Basically because I hadn't specified anything in the text of the submission, so that you didn't really know what to put in. My hope was that some of you would do what some of you actually did, and was to just assume some sort of tolerance and assume a material. One of you actually assumed gold, which was really cool, very stylish. So you just placed in something because you didn't know, you didn't have it specified in the submission, so you put it after your best knowledge. So that was very good to do. So that counts also towards the next 2 submissions. If there is some information you feel that you're missing, then it is better to actually assume what it is, so that if you haven't gotten any tolerances set or anything like that, then you just put in something that you feel. My recommendation would be to use the medium ones, which are very often used in machining. So it is a very safe bet to use when you're putting them in. So, and also for material, just choose something that's appropriate or gold. So now we're finished with this text. I move it down to the title bar. And then I need to put in the surface finish symbol. And with the surface finish symbols, you place your mouse pointer in approximately the correct location. Then you do both a left click and a right click. And then you click continue afterwards. And in this case, we need to remove material. Of course, we're going to drill holes in it and everything, so we have to remove material from this one. So material has to be removed, and we want all of the surfaces to have a surface finish of 6.3, RA 6.3, which is the mean value for the surface finish, which is also one that is very easy to attain when you are machining. So it's a very safe bet to go for. It means that they can have quite a lot of speed on their tools when they are machining it. So it's still a very nice surface to look at and touch. You won't really feel any ridges or anything. So if you go lower than 6.3, then you're putting limitations to the speed of the machining process. So 6.3 is also a nice even choice to use when you're not quite sure what you're going to have. And usually if you have something that is even finer than 6.3, it is usually because you are going to have, for example, an O-ring seal or something. Then you want a really nice surface so that you get it sealed tight for hydraulics and stuff. So then you want a really nice surface, or you have some, you want as little friction as possible, then you want really nice surfaces. But for a regular steel component, 6.3 is usually more than enough. And we click OK, and it's been set into place. Now we just need notes and the title box. So a new text box, place it approximately in the corner there, and I write in my notes, which is to break sharp edges. 0.2 millimeters at a 45-degree angle. Once I've placed it, I move the text box into the corner, just so that it looks nice over there. Most likely, if you're working in a company, they will have some sort of template for how their drawing is supposed to look, and they will have a dedicated spot for where you're going to place your notes and your parts list and everything like this. So we're just putting them where they look fairly okay to have, and they're not going to intrude too much into the space of the drawing itself. And they're very close to the rest of the text, so that it's easy to find them. So then we're going to go to the ISO part in the browser window so that we can edit the title box. We go to the ISO part, we open it up so that we get the field text open here. And then we click Edit Field Text. And in the submission, most of you managed to fill in everything in the field text. Some of you had forgotten a few points, so maybe forgotten the title, or maybe forgot the checker, or maybe forgotten revision. That might be that you had actually forgotten them, or it might also be that you just put in text in the wrong place so that it wouldn't show. That happens, so it's not a big deal. Some of you had been really creative, didn't quite know. Probably what I'm guessing is that you probably did it before we had gotten to this part in the lectures, so that you had actually put text boxes in here. So it's fair enough for this first submission, but we need to stick to this one for the next submissions. So it's not something that has been a problem when I've been grading them, because I have put grades on these first submissions, but the grades are good for everyone. so it's the only reason that I'm doing it is that I need to have an average grade for all of the submissions, including the project, so that we need to have a grade on it. But I have given you the message that it wouldn't be very important for the total grade, which basically means that you have gotten a good starting point for the total grade average. So it's a nice way of doing it, I think. So. Yeah, we're going to fill in this one. So we go to the edit properties. And my advice is always to expand this one, so this window, so that you see all of the things that you're going to fill in, and place this window beside it so that it's a bit easier to see what you're doing. So we go to the summary tab where we have the title. And this one, I've just called it amount, and I'm switching my initials for my student number. You probably have your student number as a default, I'm guessing, because it usually uses the Windows login, and since I'm an employee, I have my initials as my login instead of my student number. So, and I just put in the company name. Some of you had really creative company names, and that was fun to read when I was correcting everything. So it's always nice to have something gold and some creative company names and something like that. It's nice to have a bit of a laugh when I'm correcting. Brightens my day a bit. So just a quick tip here is also if you're a bit unsure if you put these in the correct ones, if this company line is actually the same company line as over there. I think it is possible to click this button and see it updates. Or just crash. That's a possibility also. Oh, it didn't update. You actually have to close it in order to get it to update. So that is a possibility, to just close it and open it up again, just to see that you have gotten your information in the correct place. So then we go to Project tab for the next one. And here we have the revision number. And this is what I sort of imagine happened to some of those who are missing 1 or 2 spots in the title field, was that instead of putting the revision number in there, they probably accidentally put it in on description instead, and then it wouldn't show. So it's that's always a possibility. So revision number, I'm just putting in A. Most of you used letters, some used numbers, which is no problem, but some of you used decimal point numbers, so 0.1 or 0.2. And I would advise against that. Use a whole number or a letter when you're using it, just to avoid confusion. Then we go over to status, where we're going to put in checked by and approved by. So I'll just use Torbjørn and Einar as I always do. And of course, just filling in this isn't how it happens in a company. In a company, you actually send the drawing to whoever is going to check it, and they check it, and they fill in their initials. So it's not something that you do yourself. And once that's done, I click close, and I see that I have information in all of the parts here. So that means that my title field is complete when I exit that function. So then we can save the drawing, and we can start on practice task 4. I'll just close down the drawing and the parts, and I'll start on a new project. But before I create a new project, I just want to remind you all that I saw some things when I was correcting the first submission, and I haven't been strict about it, but you are actually delivering all of your files to me, so it's very easy for me to see if you have copied someone else's file and put your name on it, just so you know. And that's going to count as cheating for the rest of the submissions. Not for this first one, so you're getting a warning now, whoever did it, if there was someone in this group. So, but I know who did it, but I'm just saying to everyone that is something that I will be able to figure out, and I can prove it. And if I can prove cheating, then you have failed. So let's just keep that in mind. It's not a problem that you're sitting beside each other and creating an almost exact copy of each other's drawing. Not a problem at all, but I am going to be able to see it if you have actually just copied the file and not done the work yourself. So then, I'm creating a new task, single user project. So project name for this one will be practice task 4A. And I go into my computer and find my H server. I go into my lecture folder, and I create a new folder there. Practice task 4A. And again, the problem with not having the correct folder being chosen right away. So I need to switch around a bit. And now I got folder practice task 4A chosen there. So I click OK, and then finish. So now my practice task 4 project is active. So I can start looking at it. Press test 5. And practice task 4 looks like this. So there's a bit more to do on this one. And our drawing is going to look a bit more complicated because we have more dimensions to put in and more stuff to show. So we start off with a new part file.
What's the first letter?
We click on the new button. Now we have to remember to choose the metric folder.
There, it says there. It says C.
And then we want a standard part in millimeters. One of the things you will see here is that you have the possibility of choosing a sheet metal part. That is, if you're going to create something from a sheet of metal that is going to be bent into shape. Then Inventor actually has built-in functions that will calculate the bend radius and stuff like that. So it's a nice one to use for specific sheet metals, but it is going a bit too deep into the program with regards to the course that we are having. So it's something that you will have to learn in a company as you are working along with it. But it isn't all that different from actually creating a part. You have some different functions that perform a bit differently, but it is easy to figure out what they do. So for this one, we'll just create a rectangle basically as the base. So I'll start a new sketch. As usual, I place it on the horizontal plane. And I tilt it to get it the right way up. And I want to place a rectangle, but I don't want to place a rectangle which goes from one corner to another corner, because I want the center of my rectangle to be in the center of my coordinate system. So I'm going to choose a different option down here. So I go down to the rectangle, 2 points, center. And it actually shows, if we look at the tooltip here, it actually shows that the first click you do is the center point, and the second click you do is one of the corners. So first I attach it to the center of my coordinate system, and now I can actually set all of the dimensions of it. And I think I want it to be placed like this. So I want this length to be that one, and it's going to be 90 millimeters. And then I want this length to be that one, so it's going to be 60 millimeters. In order to switch from one of these to the other, you just use the tab button on your keyboard. So once you've put in 90 millimeters there, you click the tab button on your keyboard, and then it switches to this one. And just to be on the safe side, before you place it, click tab once more, because then you're going to see on this one you have a padlock that shows that it has locked it to this dimension. But that's not in place on this one yet. But if I click my tab button once more, then I have a padlock on both of them. So then I'm completely sure that it's going to place it at 90 and 60. Then I can click my mouse button, or I can click enter on the keyboard, and it's going to place it. Once this is done, I can exit the sketch and extrude this plate. So we'll extrude it up to this point, and we're going to create these two afterwards. So the thickness in the middle is going to be 15 millimeters. I put that one in. And now we're just going to create these edges before we do a break.
Extrude 10.
It says 15 in the drawing.
Oh, sorry.
So then I create a new sketch and I place it on top of the plate that I've just made. I'm going to flip it to get it in my correct view here to show as much as I can of it. Now I'm going to create rectangles again, but before I do that, I want to be able to attach my rectangles to the corners of my sketch here. So what I'm going to do is to choose the project geometry option, and I'm going to just click in the middle here, because you can see now the outline of my plate has been shown in white. So as soon as I click here, I clicked once too many, I think. There. As soon as you click it, you will get these yellow lines along the outline. And they are connected to the plate itself that we just created. So that if I go back and I change the dimensions of the plate, these yellow lines will also be changed. So they are directly connected to the edges of the plate. So now I can do rectangle again. But now I want to go back to the original one where I have 2 points that I'm connecting. So I'll connect it to one of the corners down there. I'll pull it up to the top. I make sure that I get this symbol that is attaching it to the top yellow line. And then I'm going to set the width of it, which is also going to be 15 millimeters. So I press in 15. As you can see, I don't have any padlock there yet, so I'm going to push my tab button just to get it over there. So now I have a padlock on the 15 millimeter, and I also have this symbol showing that I'm connecting it to the line. So if I push my enter button now, it's going to be completely locked into place. I can do the same on the other side here. Connected to the corner. Now I move it to the lower yellow line. And I set the width to 15. Press the tab button so that I get a padlock on it. And now I actually do have the symbol for connecting it to the lower line, but it's hidden behind my dimension here, so we can't just see the lower section of the symbol. So if I click enter now, it's going to be locked into place. And I can check that it's locked into place by exiting the rectangle function. And I can see that it's fully constrained down in the corner. So it says down here that it's fully constrained. So then I know that everything was locked into place when I did this. That was what I didn't check a couple of times last week, so that I had some problems when I was doing extrudes. So I didn't check that they were fully constrained before I exited and tried to extrude it. So now I'm going to do a finish sketch. Now we can do an extrude, and we can choose both of these rectangles that we just created. The profile choice on both of them. And my total height is going to be 30, which means that it's just going to be 15 on this one also. But if you're in doubt, write in 30 minus the previous 15 you put in, and then you get the exact dimension you need. Then we'll do a 10 to 15 minute break, since we were a bit slow to start today. Then we're back. Now we're going to create the two holes that are supposed to be in the middle, and we're also going to create the slot that's going through. Now, the easiest thing to do for this one is actually not using the hole function as we have previously done for creating holes. Now it will just be to create a sketch and just extrude everything, because the slot has to be created in a sketch, basically. So we're going to do that. I'm going to start a new sketch, and I'm going to place it in the middle here on the parts. Alternatively, it could have been done in the very first sketch we did. We could have chosen to put the slot and the holes in there and just extrude around them. But now we get to do an extrude where we're actually cutting, so get to show that. I'm going to tilt it to get it the right way around. And then I'll place the slot first, and then we actually go to the rectangle part. We use the drop-down menu, and we see that we have a couple of different ways of placing a slot. We want this one to be placed in the center. So instead of using the one that's named center to center, it actually uses the center of the rounded edges and goes between those. But we're going to use one that uses the center point of the slot, and then we're going to give half the length needed. So the center point, we're going to connect the center point to the center point of our sketch. We can pull the line upwards and make sure that we get this vertical constraint on it, so that it's going to be constrained in a vertical manner there. And our slot is going to be 30 millimeters from center point of the slot to the other center point of the slot, which means that we need 15 millimeters. But we can also write 30 divided by 2, just to get the correct length there. So now we have the length of the slot, and we also need to set the width of it. And the width is going to be a radius of 5. So in this case, we need a width of 10. So write in 10, or 2 times 5 if we want to. And then we have the slot placed directly, and everything has been constrained now. So we don't need to create a rectangle and do fillets on the edges in order to get it. So we can get everything in very quickly by using the slot function, which is very nice, because you will often end up creating slots for movement and stuff like that, so, and for guiding things. So it's a thing that's very often used in designing. And actually, I think it was in 2015 version of Inventor. That was actually when they started using slots directly. Before that, it was just a rectangle, and you had to fillet the edges. So it's they are constantly improving Inventor, so it gets better and better. Then we're going to create 2 circles. So we want them to be on line with the center mark here. So I'm going to place my mouse pointer on the center mark and pull it out to the side so that I get it locked into place there. It's a bit difficult to see now, but there is a dotted line between my yellow marker at the mouse pointer and the yellow marker for the center point. I think it's a bit easier to see on your own screens if you get it, because up here it's a bit too bright to actually be able to see it. So now I'm going to place the point there, and I'm going to set a radius of 5 for it. So that means 10 in diameter, in my case here. Then I exit the whole function right now. So now I need to set the distance from the center and to the placement of my hole. So I use a dimension function here. I click the center line in the slot. And I click the center point of my hole. And according to the drawing, we're going to have, see, from the outer edge and to the middle there is 45, and from the outer edge and to this one there is 25. So what we can do is just 45 minus 25 on the length. No, I hadn't put it yet. So we put it out, and then we do 45 minus 25. That's going to place it in the correct dimension. 45 puts it out there, but then we want 25 instead in. So we place that one, we get it in here, but we can see it's still green, so it's not completely locked into place. And in this case, it means that it hasn't actually locked onto the center point here. So I just managed to place it right beside the center point, but it hasn't been constrained to it. So I need to put in a constraint. So I choose the horizontal constraint. I want the center of my hole here to be horizontally constrained to the center mark. So I use the horizontal constraint, center point of my circle to the center mark, and now it is fully constrained. So now it can't move anywhere. And just to make things easy, we already have a center line here, so we can just mirror the hole instead of creating a new one and setting dimensions. So we use a mirror, we select the circle, we select the center line of the slot, and we apply it. That was a bit easier than putting in a new circle and putting in dimensions and all of that stuff. So then we finish the sketch. And now I need to tilt it a bit because I can't see all of my sketch here. So I'm just going to tilt it a bit around here, just so that I see all of the things that I'm going to cut right now. Then I go to the extrude function, click on it, and I need to choose the middle option over here, which is that I'm going to cut material instead of add material. The top option is adding material, and the middle option is cutting material. And we're going to cut these 3 profiles all the way through. And right now it is set for a distance, and luckily it is the distance of going all the way through, but we can also choose all. That means that it's going to go through all of the material that we have available there. The all function for distance can be a bit tricky because if we have a large part that goes around here and we have some parts, some flange or something that comes in underneath here, further away, it's actually going to cut all the way through that also, because it's going to go all the way to the end of all material that is in that direction. So using the all is when you are very sure that it can't cut more than what you intended to cut. So now we've gotten the holes into place. Now we just need to set the material. I'm flipping it all around here. Like this. So for the material on this one, it says that we are going to make it from austenitic stainless steel. So I can't remember if it's up on A. It's not up on A, so then we have to go down to S for stainless steel. And there we have stainless steel austenitic. Should we click on that one? Then we'll save it, just in case. And we'll call this one a bracket. And then we can start creating the drawing for it. So we create a new file, and we have to go all the way down so that we can see all of the drawings. And we want the one named iso.idw. And we click create. Now this one, I've chosen on in the compendium, I've chosen to place it like this, and then I made a section going straight through it, and I placed the section over here, just to get to show all of the holes and the slots. So we're going to do the same. We're clicking our base view here. I have to tilt it around to get it in the correct orientation. So flip it up to the top, and then I flip it over on the side so that I get it the correct way around. It's also a bit small for this drawing, so I think I'm going to try to scale it up a bit, 2:1. That looks a bit better. I'm going to stay there with 2:1. So if I would just place a projected view here now, I would have to use hidden lines if I wanted it to be clear on the drawing that these holes go through. Either that, or I would have to use a note on my dimensions that they are going through the part. But instead we're going to use a section that shows it even clearer what's happening, so that we are just going to place this one like it is. And then we'll choose the section part. Now it wants, if we just look at it straight away, it says that it wants to use a 4:1 scale on the section. But I used a 2:1 scale on this one, and that means a 4:1 is going to be twice the size of that one. So we can't have that. That's going to be way too big. So I have to scale it down to 2:1 so that we get the same one as the original. No, I clicked the wrong one, by the way. I clicked detail. It was section I was supposed to have. So the section one, then you mark the view that you're going to create a section with. We try to get the connection to the midpoint so that we get it connected here. I place the starting point of the section line, and I'm going to pull it all the way through the parts. Now, a very few of you actually used section view on the submission, which was very cool to see that someone actually used that one. One of the submissions that used the section view had actually put the section view straight through, which meant that the two smaller holes weren't shown in the section view. So one way of avoiding that would have been to let the section view have one of these angles in the middle. So if I complete this one like this, in this case, you see that I'm only showing the slot in the middle and the top hole. I'm not showing the lower hole, because I've cut this part away so I can't see the lower hole in it. I'm just going to place the correct section view instead. So that is a possibility. If you have holes that are not in line, but you want to show them all in the section view, you can make these 90-degree angles and get it to show several planes through the part. So when I'm done pulling the line through the parts, I just right-click my mouse button, press continue, and now I get it up here. Now it says the correct scale, so that's good. So I just place it over here. And now I've already placed one, so now you can see I've gotten BB for my view here, not AA, since I showed the two-plane section earlier. This means that I have to fix mine. And if there are ways of doing it if you miss it in the original window. So what you just do is double-click the section line itself when it's marked red like this by the mouse pointer. No, not the section line, but not that one either. It's the view that you have to double-click on. So you get this red rectangle around the view. You double-click it, and then you have the label here. So you can change the label. So if I switch this one now back to A, I have an AA section instead. So now it's not going to create any trouble in a production workshop, because they're not going to be looking for the AA section. And where is it? Now we can start placing dimensions. But before we place dimensions, we want to have the center lines in place. So we go to the annotate. Now I'm not sure if you've noticed in the final drawing of each practice task in the compendium, there is usually something missing in each of them. That's just my way of getting you to use the checklist to check through if you can figure out what it is missing on each of them. But I try to get everything, try to remember everything when I put it up here in the lecture. So we're going to put in center lines, but here we have center lines going through these holes, so we can use the one where we just mark the edges of the hole so that we get a line going between these. So the center line bisector, it's called. So we put this one in on all three here. But we're also going to need some center lines on this view. So first off, we're going to need center marks. We're going to need to mark each of the holes and each of the rounded tips of the slot. Like this. And we can also put in symmetry lines here, because it is symmetrical both vertically and horizontally. So we can use that when we're going to place our dimensions. So the vertical center line that I put in is almost not visible because the section line is going through it. But it is still there. So it's nice to just have it there. Just in case later on you figure out that you're not going to do this with a section view anyway, so you remove the section view, then it's nice to just know that the center line is there behind the section line. So now we got a lot of points where we can put our dimensions in. So I'll just start with the regular dimension option. And I'll start with the length of the slot. So I'll give the length from the center point to center point. And I need to switch it to method 1B. And now you can see this one is going to be a bit difficult to read because it automatically puts the number in the middle of the line. But we're just going to place it there to begin with, and then we can move the number away from the center afterwards so that it will become more readable. So I'm going to place it a little bit above the center. Then I just exit the function so that I can move the dimension number. Probably have to zoom in a bit in order to be able to mark it. So now I've moved it a little bit away from the center just so that it's more readable. Then I'm just going to do the lengths in the bottom and from the edges across everywhere. So the bottom length, method 1B, put this one in here. It ends up quite a bit below the part itself, but that's because we have the section line there, so we basically have to put it there unless we're going to have a total crash. So we place this one. And now the nice part is that we have the center line going through the middle, so we can start giving dimensions across the center line. So that is very useful. We can do from center to center on the holes. Just place this one here. And we can do from edge to edge on this one. And we can do from top to bottom on the entire thing. Then we have everything there. We'll also need to show the heights of over on the section view here. So I'm just going to put in the total height down here. And then I'll put in the gap here just to get it to show properly. Put that one in there. And just to get this done fairly easily, I'm going to put in a dimension on the middle one here. I chose a diameter. We're just going to put it on the top one instead. will be a bit more correct with the diameter there. So I'll put this one in here, and I'm going to add tip to it. There was no room for a tip inside there, so I just need to move it outside so that I don't have these broken dimension lines on it. And since this diameter of 10 is typical, it means that it is typical for this hole, for that hole, and it's also typical for the ends of the slot, which means that the width of the slot has to be 10 also. Just give you a chance to catch up a bit, and then we'll put in parts list, tolerances, notes, and title field. Yeah. With the diameter of 10. Yeah. I can just place it all over again. So I use the dimension with method 1b, and I click on the line itself here that shows sort of the edge of the hole. Then it gets automatically the diameter sign in front of it. So I place it there, and I write in tip for it, and then you see it's breaking up these dimension lines. And that's not so good. We don't want dimension lines to be broken in this way. So we exit the dimension function. If I don't exit the dimension function, I'm just going to open up the window where I entered tip earlier. So I exit the dimension function, because then I can drag and drop this dimension. So I mark it with my mouse pointer like this, just move it over it, and then I click and I drag. So then I get the dimension on the outside instead. So it becomes a bit more readable by doing it this way. So the next point will be to create a parts list for this one. So parts list, one of the views, click it, and then OK. Place it down in the corner. And then I double click it in order to edit it. We have the table layout up here. And always, if you can't remember which one of the buttons you're supposed to press there, just let the mouse pointer hover across it a bit, and then you get the tooltip up. So it's quite easy to orient yourself here. So you get table layout on that one, and column chooser on the furthest one away. I uncheck the title because I don't need it. When we get to practice tasks 7 and 8, then we're actually going to do assemblies. So then we are going to put in proper parts lists, because then we need to know all of the parts. Then I go to the column chooser, all the way on the left side there. I remove the default ones, and I put in the material. In some cases, it might be nice to actually add not only material, but also this one named mass. Because as soon as you've set a material in Inventor, that material has all of the properties of it. So it also has the density. And from 3D model, Inventor knows exactly how much volume it has. And coupled with the density, it knows the mass of the part. And that is nice if this is something that's going to be, for an example, transported on, and the weight is very crucial to it. For example, maybe it's going to be, it's a fairly small component, but it's going to be transported by helicopter to a rig or something. Then it will be very nice to know exactly what it's going to weigh. So then putting in the mass will be nice to have there. So, but in our cases, we're content with it just using material. Click OK. And now I definitely need to fix the width of the material, because now it's over on 3 lines instead. So I'm going to drag it to the side until I'm down to 1 line. And then I put it down in the corner. Then I'm going to put in a text box to do the general tolerances. This exact part becomes quite repetitive when we're doing it here with practice tasks. So for every drawing we make, we're going to write in the general tolerances and everything. Like when I worked in Emenco, we had a special plugin module to our inventor, so that when we were in the 3D model, in the properties part, we could set the tolerances there, so medium and K for the geometric ones, for an example. And then it would automatically fill it in the notes field that we had here for general tolerances. So usually there are more automatic ways of doing stuff when you're out in a company. But those are usually custom made for that company, so that we can't really show them here properly. So instead we have to do everything by hand. General tolerances and surface finish. ISO 2768-1. In this case, we put in medium and K. ISO 2768-2, capital K. So I'll move it down to a good position there. Then I'm going to put in the surface finish symbol. Left click and then click the right mouse button and continue to place it in the correct position. And here I definitely done something wrong when I created the compendium. What it says in the compendium is RA 0.05. That's an immensely fine surface. I think you're over on Teflon grade, the surfaces when you're over on that one. So it's definitely not going to be that. So I think I don't have the Metal Trades Handbook on me right now. So we're just going to put in 6.3 there for everything. So what I had done originally in the compendium was to place also surface symbols inside the slot and the drilled holes to show that they were supposed to be 6.3. But now I've just put 6.3 for the entire part, basically, because I've probably just pushed the wrong buttons when I put the general one in there. I'm guessing that it was supposed to be larger than 6.3, so maybe it was 10.05 or something, but since I'm not quite sure, I'm not going to put something in. So then we'll put in the notes with break sharp edges down in the corner. Break sharp edges 0.2 by 45 degrees. And place it snugly down in the corner there. So then we only have the title box left. So we'll do the title box, and then we can actually start on the practice task 5 parts. So that's nice. Then we were supposed to do the entire practice task 5 today. So we're slowly getting there, catching up to where we were supposed to be. So I'll go into the browser tree here. We'll go to the field text. We'll edit that one. And again, I open up the properties. So this was the part in Imenco where we had something extra. So we had an extra tab up here where we could put in the general tolerances of our 3D model, and then it would auto fill in everything in the drawing. It was really nice to have that one. So for a title, it's the bracket. Put in the student number, company name, switch over to projects. I haven't saved it yet, so I have to write bracket in there also. And revision number A. Then I go to status. It will be Torbjörn and Einar. And the date for the approval. And I press OK. So I double check that everything has been filled in there. And once that is done, I can save my drawing and create a new project. So I save it as bracket. Then I'll close down the drawing and the part file. I open the project and I'll create a new project. New single user project. This one will be practice task 5. Need to change the folder to my H drive. So practice task 5A there. Switch a bit around to get the correct one marked. And I need to add an A there for the name. And then finish. So now I've got practice task 5 marked as my project. And I click done. And for practice task 5 we're going to create this piece, which is a bit more complex. We have this part sticking out, and we also have a slot going through the bottom. So there's quite a bit we have to do on this one. So create a new part, but I have to remember to enter it into the metric folder first. And get the standard millimeter parts. I'll start off by creating the outline of the parts, and I'm going to also create a hole in the middle for this first sketch. So I create my sketch on the horizontal plane as usual, flip it right side up. Now it remembers that it was the slot function I used last time when I did a rectangle. So now I want to do the regular rectangle, but I still want my center point to be locked to the center point of the coordinate system. So I lock the center of the rectangle to the start point there, and then I can put in the dimensions. And this one is, let's see, it is 35 wide and 45 tall. Remember to press the tab button when you have written in the dimension so that you get the padlock on it. And then you press enter. And we're just going to zoom in a bit just to get a better view here. And now we'll put another rectangle in, which is going to be the center hole. So attach it to the middle. And now it's a bit more difficult because now I have to look at what this hole is supposed to be. And it's supposed to be 11. And it's square. So it's 11 in both directions. 11 millimeters and 11 millimeters. Locked into place there. And press enter. Then I finish the sketch. And I use the extrude function, and I'm only going to extrude the outer parts here. I'm not going to extrude the center. It's going to stay a hole there. So I choose the outer parts. And the height was supposed to be 8 millimeters. Put that one in there. And then I can create a new sketch on top of that one. I'll flip it right way around. And now again I want to use this project geometry part or function in order to get these yellow lines around everywhere. So I click project geometry and I mark the surface so that I get yellow lines here. One other thing that you can do with the project geometry, if you use the pull down menu, you also have project cut edges. So that if I had something on my part here that was raised higher up, I could sort of remove it so that I would project the edges of what has been removed there for my view. We'll get a bit more into it later on, just to show how it works. Now I'm going to put a new rectangle in because we're going to create this tip here that goes out, and it is also a square, so we can use center point rectangle and place it a bit larger than the hole in the middle. And it is supposed to be 50 millimeters. So 15 and 15. Lock them into place and put them up there. And now Inventor is supposed to handle these yellow lines in the same way that it handles the blue ones once I want to do an extrude. So it should choose only this sort of outline that we have there. So if I do finish sketch, click the extrude one, and it's a bit difficult to get the correct one marked, and it might be nice to actually zoom in a bit just so that you're absolutely sure. You'll see that it changes a bit, the lighting changes a bit once you mark something. But if you accidentally mark too much, then it's not a problem. You can hold down your control button on the keyboard and then you can demark stuff. So in this case, I hit the correct spot. But if I had been accidentally hitting all of this, so that I would basically make an extension of the original plate, I could hold down my control button and click once more there, and then I will remove the surplus marked area. So the height of this one is supposed to be 6 millimeters. Click OK. And then we've gotten it in place. So we'll stop there for this week, and then we'll continue on next week. And if we're really lucky, we'll actually manage to finish practice task 6 next week. That will be really cool. Because we needed a bit more time for 7 and 8 since we're going to do several parts and do assemblies for them. So. So I'll just save this one as mount.